Hello everyone and welcome to .NET Core Central. In today's video, I am going to talk about memory caching in .NET 5. In some of my previous videos, I discussed about distributed caching, especially distributed caching using MemoryCache and Redis. There are situations where it makes sense caching data for better performance, and some of the situations are, for example, when we cache a user session. The other example of caching is some sort of lookup data like office location or employee type and things of that nature. Now for data like user session, it makes a lot of sense to cache them in a distributed cache. The reason for that is usually ASP.NET Core web applications are scaled horizontally, which means there will be multiple servers and or multiple containers, and a request to a particular server and or container is not known, which means a session created on one container might end up getting a call into another container. Hence, it makes sense using distributed cache for those scenarios. But for other scenarios like lookup data, for example, employee type, office location, and things of that nature, those things are usually immutable data and changed extremely rarely. And hence, those data, it makes sense caching in memory. There are of course advantage of memory cache over distributed cache, and first and foremost is the faster access, and of course the disadvantage is it eats up the total memory taken by the application itself. And given that the memory cache is per process, which means per container, it will have to be replicated across all the web servers or any other application that we have. Hence it makes a lot of sense to cache items which are smaller in size. Now when it comes to things like user session, it can still be cached in memory, but for that purpose we will need to create something called a sticky session, meaning a call always goes to the same server and not another one. And in those cases, an in-memory cache will work fine. But I personally will strongly suggest against using any sort of sticky session implementation. In my opinion, it just reduces your chance of scaling horizontally and keeping the services completely stateless. So having said that, the interface that is provided by .NET 5 as well as the previous version of .NET Core is called IMemoryCache, and this is something which can be used to implement in MemoryCache. So for today's example, I'm considering a scenario of user data. So I have a property called user which is name and age, and the user data, for example, for this application, let's say it does not change frequently. Now one thing we'll have to keep in mind as a best practice for always using cache, doesn't matter whether it's a distributed cache or it is in-memory cache, the cache really perform well if the data change frequency is very less, which means the data doesn't change frequently. In that case, the caching makes a lot of sense. In our example, let's say the user data doesn't change often, and this is what we are going to cache. So for that, what I'm going to do is I'm going to create a class called userCache. And the userCache class is the one which is where we are going to inject the IMemoryCache interface and cache the user data. And IMemoryCache is part of Microsoft.extensions.caching.memory namespace. So I'll just add it, and I'm going to declare a local field called MemoryCache. And then I can create void function called cache, which is responsible for caching the data. And then I can have another function called get cached user. Let's just say all the users for simplicity. So get cached user. This cache method can be either called during construction of the object, which means this is where you will get the data. And as I mentioned, it makes sense saving lookup data. So this is where you get data from database and then cache it, and the get just returns the data from the cache. So the implementation of get is going to be very straightforward, and it is going to be MemoryCache.get, and here we can use this get of user array, and we'll have to pass a key, and let's declare a key here, private constant string key. Now this can be any arbitrary key, and as you can understand that based on how you are using the cache, you might have multiple key or single key. So we're going to pass the key here, and we can return this, and let's declare this as a user array. So now this is going to return the user array, and the cache will be added. Let's change the name, instead of cache, say add to cache, and here we're going to use MemoryCache dot, and as you can see there is a set method, and this is what we are going to use, and it takes key as the key. For the set also we can pass user array, and the value for the time being just going to create a new user array, but in a real life scenario this data will come from some sort of data store. New user name equal to user1, age equal to 20, and let's copy and paste another one, 3 users. That should do it. So here we are adding users into the cache. Now when we add the user into the cache, I just so far showed only overload with 2 parameters, but as you can see it has something called as absolute expiration and memory cache option, an expiration token, and then absolute expiration relative to now. So these are few of the options. So I'm going to talk about all the options, but if we use the memory cache option, it kind of covers rest of the overload inside it. So I'm just going to use the memory cached option instead. So if I declare a option here, so if we use the memory cache entry option, there are a bunch of things we can pass here, and as I mentioned, this covers everything that we need that we can pass in the other overloads. First, let's talk about the expiration. So in any caching mechanism, there are basically 2 types of expiration. One is a sliding expiration and one is an absolute expiration. Sliding expiration is basically, as the name suggests, it's a sliding window, meaning if we set the sliding expiration as 30 seconds, if a cache is accessed within 30 seconds, its lifetime will be renewed for another 30 seconds. So as long as the cache is accessed within the time frame, the cache will continue to extend for infinite amount of time. And the other expiration, which is absolute, which as the name suggests is an absolute value, which means after that time the cache will expire whether it is being used or not used. So here for memory cache entry option, we have absolute expiration, which is after the time it is going to expire, which can be any date time offset, and then you have absolute expiration time relative to now. That's basically from now at what point in time or at after how many minutes or seconds it is going to expire. As you can see, the absolute expiration relative to now is a time span, whereas the absolute expiration is a date time offset, because that's the absolute time, a specific time. This is from now for how many minutes or seconds you want it to expire. And then the other thing that I discussed is the sliding expiration. Again, this is also a time span, and as the definition is given here, it gets or set how long a cache entry can be inactive, that is not accessed, before it is removed. Now for sliding expiration, the problem is if within the sliding expiration, if the cache is accessed again and again, the cache will never expire, which might cause stale data. So the best practice is to use an absolute expiration also along with sliding expiration, so that you don't get into that particular situation. So in our case, we can give a sliding expiration of time span dot from seconds 1, so it's 1 second sliding, and then we can give an absolute expiration relative to now is time span dot from seconds and 10 seconds. So we're just saying sliding expiration is once again, whereas even if it is continuously accessed within that time, after 10 seconds it will for sure expire. Post-eviction callback is another interesting feature, and post-eviction callback is basically it's a callback that will be fired after a cache entry is evicted from the cache. Meaning when the cache entry is removed from the cache, maybe due to a sliding expiration or absolute time expiration, the callback which is set as a part of this property or an array of callback, those will be called back and you can do some functionality inside of that. You can think about the situation where you want to auto reload your cache, so after the expiry it will trigger your callback and you can autofill your in-memory cache at that point in time. For me, most of the time I check if the cache object is null, then add it to the cache, otherwise just get it from cache. Then priority is something, is basically when there is a memory pressure at that point in time, the priority comes into play. The higher priority objects are kept in the cache, lower priority objects are evicted from the cache. And then finally here is the size. What is the size of the cache entry that we want to set? Now the size can be set at a particular cache entry level or for the entire memory cache, and the entire memory cache size limit setting I'm going to show later. So now let's say that's all we wanted, and this is the option which we can pass into the set cache. Now as I mentioned, I personally prefer adding the object into the cache if the first time when the object is accessed, if it is null, add it to the cache. Similarly, after the cache is expired, when next time it will be called, it will be added to the cache. So I'm going to use the same mechanism here. So for that, what we can do is we can say if MemoryCache dot TryGetValue, and here key, and then we can give the value. So for the value I can declare here user array users equal to null, and I can pass here users. So I'm going to put a not. So if we don't get the value, then what do we do? Here what we can do is to the add cache we can change the implementation and we can pass user array users, and then here it can be users. So if we did not get the value, we can say users is equal to new user array, and then we can say add to cache and we can pass users, and then finally we can just return users. So the way the code flow will go, first we declare users. Actually I don't have to make it as null. First we declare users, and then we'll try to get the value from the cache into users. TryGetValue will return a bool. So if we don't get any value, we will set the user into this new array and add it to the cache, and the cache addition happening here, and then return user. But if the TryGetValue already returns the user, it will not go inside the if statement and it will just return the user back to the caller. So as you can see, it is pretty straightforward. Now we did this. Now it's time to inject the IMemoryCache into the dependency injection container. So if we go into startup, injecting IMemoryCache is extremely straightforward. So what we can do is we can do services dot AddMemoryCache. This is an extension method which is already provided by the cache.memory namespace, and this is going to inject the IMemoryCache into the dependency injection container. Now here also, as you can see, there are two overload. One is empty, the other one takes an action to set up memory cache option. So if we do setup action, we can use setup action dot, and as you can see, this one has a size limit. This is what I was talking about. It sets the maximum size of the entire cache. So that was it does. Now one thing to keep in mind is that the size limit of the cache size is the size limit property does not have any units, which means it's just a long value. It doesn't have whether it's in megabyte or kilobytes or anything like that. So the cache cache entries must specify the size in whatever units they want it to be, and that size unit is what will be used as the limit here as well. It is a little bit confusing in my opinion, but this is what it is. And then apart from that, we have something interesting which is called compaction percentage, which is the amount of compact the cache by when minimum size exceeds, meaning how much percentage of cache should be compacted when the cache minimum size exceeds. And this is a percentage, so you can provide it in the form of, as you can see, it's a double. So for 40% you can provide it in the form of 0.4, for 50% 0.5, and so on and so forth. So compact percentage is what which will be used when the cache exceeds the maximum size. And during the compaction, as I mentioned earlier, the cache will be evicted, and if you have a callback, those things will be called back. During compaction also, the cache priority will come in handy, where it will look into the priority of the cache, and based on that it will decide which cache to compact, which not to. So I'm not going to use any of this property, so I'm just going to add memory cache. And then finally I'll go into the user controller, and here I'm just returning a user array. Instead of that, I'm going to create a constructor, and in the constructor I am going to inject an iCache manager. So let's extract an interface. Let's go and inject IuserCache class. And let's declare user cache here, and then here we can do user cache dot get cached user. We can return that, and then also I'll have to do services dot add singleton, and here user cache. And as you can understand, given this is managing an in-memory cache, it makes sense keeping it as a singleton. So that's what I did. Now I'm going to put a breakpoint in the user cache so that we can walk through and see what is going on. And as you can see, this is a second, this is 10 seconds. So after 10 seconds, the cache should expire. So let me run this project now. So now if I try it out, execute, see that this return false. So it's going to go here, and then it is going to try to add the user to the cache and then return the user that was already done. And it's returning the user here. Let's execute again. Comes back. This time it could not get the data from the cache because it took more than a second, so it will try to add again. So let's increase the frequency here a little bit, 30 seconds, and let's make this as 90 seconds. And now let's try it out. So after it starts up, I'm going to go ahead and try out this function, execute. First time it goes inside and it adds to cache, so I'm going to do an F5. We get the user. Second time we go in, as you can see, it got the cache, so it returns from there immediately. Third time, same thing, because it's less than 90 seconds. So we'll wait for 90 seconds, and after that we are going to try out, and we are going to see that the cache again is going to recreate because the absolute expiration of 90 seconds would have passed. So even though we have accessed it, it will go out. Now we try it again. It is still less than 90 seconds, and it is still less than 30 seconds we are accessing the cache. And I'm going to fast forward this video a little bit so that we go beyond 90 seconds. And now, as you can see, the cache is expired, so it is adding the cache back into the in-memory cache, and then it is going to return it from the cache. Now if we execute, now again it is just going to go through and return from the cache. So as you can see, it was extremely easy to add a memory cache and then also add sliding expiration, absolute expiration relative to now with just few lines of code and have an in-memory cache set up so quickly. We did not have to do anything ourselves to manage the lifetime of the expiration. The cache as such, if you just want to create a cache, yes, you can just create a singleton class, and as long as you have a local variable, it will be cached throughout the lifetime of the process. But the complexity comes when you want to manage the life cycle of the cache. What is the sliding expiration, what is the absolute expiration, and things like that. That's where the IMemoryCache comes really handy. The other thing which is also very critical is the size of the cache, and the size limit that I have shown earlier comes very handy to make sure that your cache size does not grow infinitely due to a buggy code. If you have the size limit, your cache will be truncated after it reaches the size limit, and that's where we can use the policy of how much percentage of the cache should be truncated and things like that. So these features are really handy and helpful when it comes to managing in-memory cache. So this is all I wanted to cover for today's video. If you like this video, please give me a thumbs up, and if you are new to my channel, if you think you are getting value out of my channel, please subscribe to my channel, and thanks so much for watching this video.